Okay, hi Shantae. I'm going to do a lesson on the classification of real numbers for you right now. Okay, so we're going to talk about what are the different categories of real numbers today. I'm going to start from the simplest and then go to the more complicated ones. Okay, the first type of real number is the kind that we count with. Okay, so if you want to think about numbers, just think like, okay, what are numbers? 1, 2, 3, 4, 5. These are numbers. Okay, so that is the first type of number. Those are the ones that we count with. So because they come to our minds naturally, we call those natural numbers. Okay, and they are the whole numbers that start with 1, and they're all positive. Okay, and there's no number in between them. Okay, it's just 1, 2, 3, whole numbers. And this goes on and on and on into infinity. Okay, these are all natural numbers because we count with them and they come to us naturally. And then there's another category that's a little bit more complex or complicated than this one, and that's all the natural numbers plus a 0. Okay, so besides the natural numbers, if we include 0 in this kind of numbers, we call these whole numbers. So it's all of these numbers from 0, starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 blah. So going all the way to infinity. Okay, so we add a little bit more of an abstract number. Okay, because we don't really start counting with 0, we count with 1. Okay, but 0 is also a very simple number. Okay, so these we distinguish from natural numbers. Okay, so whole numbers include natural numbers. All the natural numbers are included in the whole number system. Okay, it's just that 0 is the one that makes these two different. Okay, and then the next level, if you will, okay, the next category of numbers are all of these whole numbers plus their opposites. Okay, so like if we were to start with 0 again, 0, 1, 2, 3, 4, 5, what are their opposites? Well, the opposite of 1 is -1, the opposite of 2 is -2, the opposite of 3 is -3, and so on and so forth. So if we can think of them as all of these positive whole numbers, and then we take a turn at 0, so we include 0, and then we come to all of the negative forms of the whole numbers. Okay, so all of positive whole numbers and negative whole numbers. 0 is not positive or negative. It doesn't belong to in these two categories. Okay, but it's kind of like the turning point, if you will. We call this set of numbers that includes all the positive and negative whole numbers, we call those integers. Okay, so integers are actually what we use most often in algebra. Okay, so these are all of the whole numbers, basically. The numbers that we usually count with and, that we usually deal with. Well, what are the numbers that, besides these? Naturally, we think about decimals and fractions. Okay, so when we talk about numbers that go between the whole numbers, we get into the realm of decimals and fractions. So that's the other whole big category of real numbers, are the ones that are between the whole numbers, namely decimals and fractions. Now, decimals and fractions are basically the same thing because they all show a part of a whole, right? They all show a part of a whole number. So for example, 1.1 is made up of a whole number, 1, and another part of a whole number, a 0.1 part of a whole number, or 10%, right? Or 1 out of 10. Now this position behind the decimal is called the 10th place. T-E-N-T-H, 10th place. Okay, so that means this 1 is placed over, is 1/10. If you have 0.2, this 2 is also in the 10th place, so that means it's 2/10, or 2 out of 10. This can be simplified to 1/5. These are equivalent fractions. This fraction is equal to this fraction, and this fraction is equal to this decimal. They're all equivalents. So if a number can be written as a fraction, then it is considered a rational number. This is the definition that the textbook uses as rational number. Now, I already said that these are also rational numbers, but they're not fractions. Well, actually they are. A whole number can be written as a fraction, right? 15 is a whole number. It can be written as a fraction if you just put it over 1. A negative number can also be written as a fraction as long as you put it over a 1. So these numbers even can be expressed as fractions. That's what makes them rational numbers as well. Okay, so these are rational numbers. Anything that can be written as a fraction, okay, these can be written as a fraction. So these are also rational numbers. Rational numbers. Okay, so I want to talk about like the in-betweeners real quickly right now. Okay, the numbers that are between the whole numbers, okay, or between the integers. Okay, if we want to write, so a number between -4 and -5 is -4.5, okay, halfway between. So we can change this decimal into a fraction. Now this is a mixed fraction, but it's a fraction nonetheless. If you can write it as a fraction, it is -4, and then this 5/10 is placed over the 10, 5/10. This has 3 places, so this is 10, hundredths, thousandths. This means this is 2 out of 1,000. So this is 2 out of 1,000 if you write it as a fraction. Here's another example. Think about a number between 1 and 2, such as 1.15. Okay, again, this is the 10th place. This is the 100th place. So this means this is 1 and 15 over 100. 1 and 15 over 100. And this can also be simplified by dividing both sides by 5, and you get 3 over 20. Okay. These are, so all of these numbers, okay, all of these numbers from the negatives to the positives and all the numbers in between them, all the numbers in between them are all rational numbers, okay, because they can be written as a fraction. Okay, now there are also numbers that are in between, okay, whole numbers that cannot be written as a fraction, and we will talk about that right now. Those are what's called irrational numbers, okay? Since they're not rational numbers, they must be irrational. Okay, so the biggest category, if you will, of irrational numbers come from here, and I'm going to explain right now what they are, okay? First, let's talk about perfect squares, okay? Perfect squares are rational numbers. What are they though? They are the number you get when you square another number. When you square a whole number, like these, okay? When you square them, you get a perfect square of that number. So if you square 1, you get 1. If you square 2, that's 2 times 2, you get 4. If you square 3, right? If you square this, you get 9. If you square this, the 4, you get 16. So on and so forth. So all of these numbers are perfect squares. If you take the square root of these numbers, you will get this, right? If you take the square root of 2, you get, of 4, you get 2. If you take the square root of 36, you will get 6. So all of these numbers, you can take the square root of, and you will get a whole number. But notice that between 25 and 36, there are a lot of other numbers. What happens when you take the square root of those numbers? What happens when you take the square root of those numbers? So for example, between 25 and 36, you have 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. None of these numbers are perfect squares, but you can still find their square root, can't you? Yes, you can. You can put that into the calculator. And if you take the square root of 26, you will get a number that's 5 point, and then a very long string of decimal after. Okay, so you can see that the square roots the square root of these numbers are very complicated. They have a very complex decimal place, okay? So what happens, what does that mean though? It actually means that when you take the square root of these numbers, like a 29, okay, that's not a perfect square. When you take that square root, you're going to get a number with an ongoing decimal. This is called a non-repeating, non-terminating. It does not end and it doesn't repeat. There's no pattern that you can see here. There's no pattern here that repeats, and this decimal can go on and on and on. Okay, if you do it on your calculator, they won't show you that many places, but it really does go on. So you cannot really express this as a fraction anymore, because in order to express it as a fraction, you need this to stop somewhere, right? If you had 5.38, you can express that as 5 and 38 over, and then you just have to count. There are two places, so this is 1 with 2 zeros out of 100. But if this keeps going, then you don't know what goes here anymore. You cannot determine the denominator, so you cannot write it as a fraction. Okay, so that means all of these numbers, these radical or square roots of these whole numbers, okay, are irrational numbers because we cannot express them as fractions. And a rational number has to be something that you can express. Let me show you. It has to be a number that can be expressed or written as a fraction. So, to recap real quickly, if you have a perfect square, then when you take its square root, you get a rational number because you get a whole number. But if you take all other whole numbers and you try to take their square roots, then you will get an irrational number. Okay. So let's look at an example. So here is a fraction. So is this rational? Yes, of course, because it's a fraction. Okay. If you were to write it as a decimal, it would repeat. So let's but you know, other numbers that cannot be written like this, if you were to write them as decimals, they would not repeat. Okay. Let's look at some examples. This is number 1, your homework. Negative the square root of 64. Okay, I'm going to separate the negative from the radical 64 and then try to solve this part first. What's the square root of 64? Okay, well, is 64 a perfect square? Yes. 64 is the square of 8. So the radical 64 is 8. Since there's a negative in front, the answer is negative 8, which is an integer then. Okay, so this is an integer. Okay, this, if you solve this, it becomes negative 8. Okay, actually, we don't call that solving. I'm sorry. You call that simplifying, okay? When we simplify this, we get negative 8. And then we have to determine what kind of a number is negative 8. Is it rational? Yes, because it is an integer. It's not a whole number, however, and it's not a natural number, but it is a rational number. So it falls in the category of integer and rational number, okay? Integers are included in rational numbers. All of these are included in rational number, okay? But a number like negative 8 only belongs to this category and this category, but not these two. So let's recap. Real numbers have two major categories: irrational numbers and rational numbers, okay? We learned about the rational numbers. These are the ones that you can write as a fraction, like P over Q, okay? These two numbers have to be integers. They can be positive or negative, doesn't matter, but they just have to be integers. Okay, they cannot be fractions themselves. The P cannot be a fraction and the Q cannot be a fraction. Okay, so if we were to write them like as concentric circles, as like you always see, if this circle represents all the rational numbers, then in this category, okay, you will have all the rationals. Okay, that's all of this. All of this is rational. But then inside this circle, there are some numbers that are in this circle but doesn't belong in this category. Okay, these are the integers. And then in the integers, we have whole numbers. I'll use a W. and natural numbers. Natural numbers is a smaller category than the whole numbers, okay? But they're almost the same. They only differ by one number. Whereas integers includes all of these as well as the opposites. And then rational numbers includes all of the whole numbers, all the integers, plus all of the in-betweeners. Okay. The other category of real numbers then is irrational number, and these are all of these radicals or square roots of numbers that are not whole numbers. I mean, that are not perfect squares. Sorry. This is a whole number, but it's not a perfect square. If you take the square root of a number like that, you will get an irrational number. Okay, so these are basically the two categories. And I hope that helps you solve your problems and your homework. Okay. Yeah, do your best, and then I will send you the answers very soon. But I want you to take a shot at doing the questions yourselves first. Okay, so I will send you the answers probably in about 24 hours to give you a chance to do them first before you look at the answers. Okay, good luck. I will talk to you tomorrow.